Hi there guys, welcome to this video on sigma notation. Now, sigma you may have come across in stats, and that's the lowercase sigma sign. We use it for standard deviation, but the uppercase version looks like that. And you may have seen it in your lower years as sum of fx over sum of f. And therefore you should understand that this symbol just means the sum of, but I'll show you what it looks like. So this is a easy question basically. It's a fancy way, it's a really efficient way, not fancy necessarily, of finding the sum of a sequence, that doesn't make sense, find the sum of a series. But rather than writing in a long sentence, we just draw a little pretty diagram. And once you understand what the diagram means, it's dead easy. So this bit here really should be in brackets. And this is our sequence or series. I can write sequence for the minute because it's only a series when we add them up basically, or put pluses in the middle. This is our starting value, that's where we're going to start from, and this is where we're going to end. And it basically means find the sum of this sequence when we start inputting at 1 and we stop inputting at 6. So for example, when r is 1, what do we get out of this sequence? 4 ones. 4 plus 2, you get 6. When r is 2, we'd have 8 here. 8 plus 2 is 10. When r is 3, 12 plus 2 is 14. I think you've got the gist of it now. So I'm just going to pop all these on. You can see these keep going up in 4s, so I can keep doing that as well. So that is the sequence, or series, and basically it's asking me to find the sum of them between this range here, between the start and this end. So obviously I can add those up. However, let's just imagine it's a bit more complex. The difference between these was far greater. If that is the case, you may not, well, you wouldn't need to find all of them. You could just find the first and the last one, and you could use your sum of a series formula. Now, there's 2 of them. See if you can remember them. I probably should have said, because there has a constant difference, I know this is now an arithmetic sequence, hence why I'm writing the formula for the arithmetic series. But we can also use a slight variation on this, which is first plus last, because that is all this bit represents. And if you're unsure what I'm talking about, go back and look at the proof video for the arithmetic series. So I can see there's 1, 2, 3, 4, 5, 6 terms. So the sum of 6 terms is going to be 6 over 2, 3. The first was 6, plus the last is 26. So that's just 34 times 3, which is 102. I could have used this formula, so it's a little bit more work for me, and I could have just done that. But obviously, please remember, if there's many steps, you're not going to do that. You're going to use a more advanced formula. The bit you'll go wrong probably is this number here. You might say that's 5 because 6 take away 1 is 5, but just think about it and you'll realise there would be 6 terms there, not 5 terms. Let's have a look at another one. This one looks slightly more complex. I've changed the letter, so K's. With sequences you're used to using N's. We can still use an N, we can use an R, we can whatever we want to. So we tend to use K's and R's and just to make it look a bit different. Okay, so we're going to start at 3, end at 7. So when k is 3, what are we getting out of here? So that'd be 5 times, let's just write that down actually, 5 times 3, so k take away 1, 3 take away 1 is 2, so that's 45. So when k is 4, we're going to have 5 times 3 cubed. When k is 5, we have 5 times 3 to the power 4. I'm just going to write them all down, why not? It's only short. So 5 times 3 to the 5 and 5 times 3 to the 6. I'm just going to type this into my calculator really quick. There's a limit to my multiplication. 81 times 5. Should know that one. That's easy, isn't it? Okay. So when you're looking at this, the first thing you've got to do is work out, well, what am I dealing with? Am I dealing with an arithmetic series, or am I dealing with something different? And the only different thing there is really, is at this stage anyway, is a geometric series. So with a geometric, you can see it's not a constant difference every time. You have a constant ratio. What is that? It's 3. So we have a to be 45, and we have our common ratio to be 3. I just looked at what I'm multiplying here, or just did that divided by that, or any of these terms divided by the previous one, and you get 3. So we've got to write the formula for sum of a geometric series. Now let's focus on the bottom part. Alright, that's bigger than 1, so I'm going to go for this. So therefore my formula would be r to the n minus 1. How many terms have we got? 1, 2, 3, 4, 5. Again, a lot of people are going to go wrong here and put 4. So the first term was 45. The common ratio was 3. We're raising it to 5 terms. Take away 1. It should be putting pluses in here, by the way. I'm just going to add those in. It's upsetting me. And that's going to all be divided by 2. So it's just a matter of popping this in your calculator now, which I'm going to do. And you get you get 5,445. So 1 was arithmetic, 1 was geometric. You've got to spot the difference and then use the correct formula. There's one more we're going to look at. So this time we have a start, but we don't have an end. We have a pretty simple sequence. But we're told this time when we find the sum, it's actually equal to 294. So let's find the value of k. Right, so let's have a think about this. So when r is 1, what are we getting out here? We're getting 8. When r is 2, we're getting 11. When r is 3, we're getting 14. And that's going to continue. And we know the sum, we don't know how many terms there are, but we know the sum is 294. So what we do know, it's arithmetic, so we know a is 8, and we know the constant difference is 3, and we know the sum is 294, but we don't know how many terms we're dealing with. So let's just write a formula down. We also don't know the last one, so the only formula I'm going to be able to work with is this one here. Okay. Right, so let's start putting things in. So we know the sum is 294, but we're unsure how many terms there are. We know a is 8, so 2 a's is 16. We're unsure on the number of terms, but we do know the constant difference is 3. So you should be able to see that we can do a little bit of tidying up here. So if I'm going to multiply by 2 to both sides, and that's going to get me 588. I think that's always a good move, just get rid of that. Now, I'm just going to really do this slowly. So this is going to be expanded, this bracket here, 3 lots of this. So we're going to have plus 3n minus 3. Let's tidy this up. So we've got 13 plus 3n. And that will give me, so 3n squared plus 13n minus 588. And you'll see here I've got myself a quadratic. Now I'm a little bit fearful at this point because I just made these up, so I'm hoping this works. I don't really want to try and factorize it with these numbers, so I'm just going to put it in the quadratic formula real quick. So we've got 13 minus 588. Super. Right, so when you do that, oh, why have I gone for n's? Sorry, let's just change that to an n, and that should make more sense to you now. but I really should have put k's in here from that original formula. It's just a habit. So n is 12. Now, when you use the quadratic formula, you also get another number, which is a minus number. And it should be, well, that doesn't make any sense anyway, because it's not an actual whole number term, which doesn't exist, but also the fact that it's negative, you can't have a negative amount of terms. So you're only ever going to take the positive one. So what that means is after the 12th term, the sum of the first 12 terms, I should say, is 294. So hope that makes sense. Go away and practice. Best of luck.